Hello everyone, today we're gonna do the exercises from Cambridge Primary Science Learners Book 4. Unit 2, Energy, 2.2, Energy Transfers. Focus. Question 1. We can think of the way energy moves from one object to another object as an energy chain. Here is an example of an energy chain for drying washing in the sun. Complete the energy chains for the energy transfers in the pictures. Let's look at the pictures. Picture A is showing that a donkey eating grass. The donkey gets its energy from eating grass. The grass, like all plants, gets its energy from the sun through photosynthesis. The energy from the sun is stored in the grass as chemical energy. When the donkey eats the grass, this chemical energy is transferred to the donkey's body to power its movement and life processes. So we can write the energy chain like this. Energy transfers from the grass to the donkey. Let's look at the picture B. Picture B is showing the air balloons. There is an energy in moving air that makes the balloons fly. So we can write the energy chain like this. Energy transfers from the air to the balloons. Let's look at the picture C. Picture C is showing that cooking meat over a fire. The fire is a source of energy for cooking the meat. So we can write the energy chain like this. Energy transfers from the fire to the meat. Let's look at the picture D. Picture D is showing that a person is sitting in front of the TV set. So when we turn on the TV, there is a sound energy transfer to the person, and the person can hear and watch the TV. So we can write the energy chain like this. Energy transfers from TV set to the person. Practice. Question number 2. Why does a block of ice melt if you hold it in your hand? The heat energy from your hand is transferred to the ice, which makes the ice melt. Question number 3. The picture shows a spinny top twine. What form of energy makes the twine walk? Is movement energy. Question B. How does the energy make the twine walk? Use the word's energy and transfer in your answer. There is a transfer of movement energy from your hand to the twine to make the twine move. Question number 4. The picture shows a solar water heater. Draw an energy chain to show the energy transfers that happen to heat the water. So, before we can write the energy chain, you have to know that how the solar water heater works. So let me explain how it works. A solar water heater works by using the sun's energy to heat water. The system consists of two main parts: solar panels, also called collectors, and a storage tank. The solar panels are usually flat, dark-colored panels mounted on a roof where they can absorb sunlight. The panels contain pipes or tubes filled with water or a special heat transfer fluid. The sunlight heats a liquid inside the panels. The heated fluid or water then flows through pipes to an insulated storage tank. Inside the tank, the hot fluid transfers its heat energy to the cooler water in the tank through the heat exchanger. The now hot water is stored in the tank ready for use. Meanwhile, the cooled down fluid cycles back to the solar panels to be heated again, and the process repeats. When you turn on a hot water tap in your house, the preheated water from the tank is supplied for your use. So, we can write this energy chain like this. The sun's light energy is converted into heat energy by the solar panels, which then transfers that heat to the water, giving it the potential to do work, like run a hot shower. Challenge. Question number 5. Class 4 investigated energy transfers. They measured the time it took for the bee in a blob of petroleum jelly to 4 of a spoon in hot water at different temperatures. Here are their results. Water temperature in degrees Celsius, time for B to 4 off in minutes. So at 40 degrees Celsius, it takes 12 minutes, 50, it takes 10 minutes, 60 degrees Celsius, it takes 8 minutes, 70 degrees Celsius, 6 minutes, 80 degrees Celsius, 5 minutes, 90 degrees Celsius, 3 minutes, 100 degrees Celsius, just 2 minutes. So the question is, draw a dot-to-dot graph of the results. So let's draw this. This is a dot-to-dot graph of the results. Question A. Why did the bead fall off the spoon? The heat moves from the hot water to the spoon. The heat moves from the spoon to the petroleum jelly and melts it, which makes the bead fall off. Question B. At which temperature did the bead take the longest time to fall off the spoon? At 40 degrees Celsius. Question C. At which temperature did the bead fall off the spoon quickest? At 100 degrees Celsius. Question D. Describe any pattern that you can see in the results. The bead falls off faster when the temperature is higher. Question E. Write a reason for the pattern. The hotter the water, the more energy it has that can be transferred to the spoon. Question F. Predict how much time it will take for the bead to fall off the spoon if the water temperature is 30 degrees Celsius. Add this data point to your graph and join the dots. So if the water temperature is 30 degrees Celsius, it will take 14 minutes. And this is a graph for the result. 2.3 Energy changes. Focus. Question 1. Identify the energy changes in each of the pictures. Write the name of the form of energy in each of the boxes to show how energy changes form. The picture A is showing the light bulb. It has electrical energy, and when we switch on the light, it gives heat energy and light energy. The picture B is showing the electrical kettle. It has electrical energy, and when we plug on the kettle, it gives heat energy. And when the water is boiling, it gives sound energy. Picture C is showing rubbing the hands. So it has movement energy, and when we rub our hands, it gives sound energy. After we rubbing a while, and it will give heat energy. Picture D is showing knocking the door. It has movement energy. When we knock the door, it gives sound energy. Practice. Question number 2. Sometimes the form of energy changes when the energy is transferred. Look at the pictures and fill in the table for each picture. So let's look at the picture A. Picture A is showing a pot on the stove. So what form of energy is transferred? When the stove is turned on, it provides heat energy to the pot. So where does the energy go to? The heat energy is transferred from the stove to the pot, which in turn heats the food inside. So that's the form of energy change. If so, how? No, the energy remains as heat energy as it moves from the stove to the pot and then to the food. The process is just a transfer, not changing. Let's look at the picture B. The picture B is showing drilling a wall. What form of energy is transferred? An electric drill gets power from electrical energy. The motor inside the drill converts this into the spinning motion of the drill bit, which is movement energy. So where does the energy go to? The movement energy of the drill bit is transferred to the wall and surrounding environment. That's a form of energy chain. If so, how? Yes, the movement energy is transferred into sound energy and heat energy as a drill bit walks on the wall. Let's look at the picture C. Picture C is showing an electric fan. What form of energy is transferred? The fan uses electrical energy from an outlet. Where does the energy go to? The electrical energy is transferred to the fan's motor and blades. That's a form of energy chain. If so, how? Yes, the electrical energy is primarily converted into movement energy and some sound energy and heat energy. Let's look at the picture D. Picture D is showing the jumper is jumping on the trampoline. So what form of energy is transferred? The jumper has movement energy as they move downward. So where does the energy go to? The energy goes to the trampoline. That's a form of energy chain. If so, how? As the person bounces, there is friction between the springs, the mat, and the frame. This friction converts some of the movement energy into heat energy and sound energy. Let's look at the picture E. Picture E is showing the sunflower plant. So what form of energy is transferred? The sun provides light energy. Where does the energy go to? The light energy is transferred to the plant. That's a form of energy chain. If so, how? Yes, the plant uses light energy to perform photosynthesis, converting it into strong chemical energy in the form of glucose, like food. Challenge. Question number 3. Read the sentences and then answer the questions. Vickers' classroom is cold and dark in winter. Before Vicker starts writing in his workbook, he rubs his hands together. The teacher switches on the light so the class can see the whiteboard better. The teacher shows the class a video on her computer. At break, Vicker eats a banana. He then plays football with his friends until he hears the bell ring at the end of break. Question A. Why does Vicker rub his hands together? To make them warm. Question B. Draw an energy chain to show the energy chain when he does this. So movement energy chain to the heat energy. Question C. Describe the energy chain that makes the light work. Electrical energy is chained in the light bulb into light energy. Question D. Draw an energy chain to show the energy changes that happen in the teacher's computer. So electrical energy is chained into the light energy, heat energy, and sound energy. Question E. Where does Vicker get energy from to play football? From the banana. Question F. Draw an energy chain of the energy changes that allow Vicker to kick the ball. So energy in the food is chained into the movement energy in the legs. Question G. Name the form of energy that tells Vicker that break has ended. Sound energy. Why is he able to hear the sound? He is able to hear the sound because the sound energy is transferred from the bell through the air to Vicker's ears.